Hey guys, welcome to this next video on abstraction and inheritance. We're going to have a look at what inheritance is and how we can implement the concept in Python using abstract classes, abstract methods, and we'll have a look at method overriding. So abstraction is the method of organizing things into groups or families based on common attributes. Inheritance is an object-oriented programming principle that lets us define an is-a relationship between classes. We represent this relationship as parent and child classes or superclasses and subclasses. Inheritance allows a child to inherit all the attributes and method of the parent class. So any attributes or methods that exist in shape will also belong to rectangle and circle. This is good as it lets our code be less repetitive and more reusable and flexible. A rectangle and a circle may have methods and attributes in common, such as the color, but may also need different behavior for things such as area or perimeter, since these are calculated differently based on what shape it is. So the behavior that's common can go in the parent class, and then children classes are able to override this behavior as necessary. Let's try and implement this inheritance relationship between a shape, rectangle, and circle in Python. Alright, so as you can see, here we have the code for three classes: shape, rectangle, and circle. The shape has an attribute color and methods for getting the area and perimeter, but these methods haven't been implemented yet since we don't have enough information in the parent class to do this. So I've just written pass to leave this as an unimplemented method. In Python, we can represent the parent of a class by putting the name of the parent in parentheses after the name of the class. So in this example, shape is the parent of rectangle. So I'm going to write class rectangle and then in brackets, shape. And I'll do a similar thing for circle. Now, to allow us to better make this implementation use inheritance, Python has a concept called abstract classes and abstract methods. An abstract method is one that doesn't provide an implementation and expects the subclass to provide an implementation. So getArea and getPerimeter are good examples of this. We don't want to implement them in shape, but we're going to expect that rectangle and circle will provide their own implementations. An abstract class is a class that has one or more of these abstract methods. An abstract class also can't be instantiated. So in this case, it doesn't make sense to create an instance of shape that doesn't have a type. So we can't directly instantiate shape, but it does make sense to create an instance of rectangle or circle or any other subclasses of shape. To make circle abstract, first we need to import the library that allows us to do this. So at the top of the file, we'll write from ABC, which is the name of the abstract class library. And then we want to import two things. We'll import capital ABC, which is the name of the base class for all of our abstract classes, and abstract method, which is the decorator that we apply to any methods which we want to be abstract. To make shape an abstract class, we'll set the parent to ABC in a similar way that we set the parent of rectangle to shape. So I'll put class shape and then in brackets ABC. Next, we want to specify which of the methods in shape are abstract. So in this case, like we said earlier, getArea and getPerimeter are abstract methods. So to represent this, we put the abstract method decorator over these methods. So since shape is an abstract class with abstract methods, we can't create an instance of it. If we try to create an instance of shape, like I've done here, when we run the code, we'll receive an error. The error says can't instantiate an abstract class shape, which has abstract methods getArea and getPerimeter. So we can only create an instance of a subclass that's overridden these methods. Next, as you can see, we have some repeated code between rectangle and circle. So both of the classes are initializing self.color in the constructor, and both of them have the same getColor method. Since both are inheriting from shape, we can remove this code as the attribute and method are both inherited from the parent class. When creating an instance of a child class, Python doesn't run the constructor of the parent class by default, so in the constructor for rectangle and circle, we need to call the constructor for shape manually. To do this, we can use the keyword super, which is a way of getting a proxy object of the parent class. So on this object, we can now call the init method. And since this constructor takes in color, we'll pass in color. We'll do the same thing in the circle class. As you can see down the bottom of the code, I've created an instance of circle with radius 14, and then I'm printing the color and the perimeter of the circle. So let's try and run this code. So it's saying perimeter of blue circle was 87.976. So this code successfully created an instance of a circle, initialized the color using the constructor of the shape class, and then overrode the abstract method for getting the perimeter. Now suppose I forgot to implement getPerimeter for the rectangle class. So let me just delete that function. Now when I try to create an instance and call that method, I'll get an error. When we run this code, you'll see we get the same error as before, can't instantiate abstract class rectangle with abstract method getPerimeter. So since we haven't overridden getPerimeter, we're inheriting the abstract method from shape. So having abstract methods in a parent class is a way of ensuring that a collection of methods are implemented in each class. You can think of an abstract parent class as a template for all subclasses. Alright, so the last thing we'll have a look at is how we can override default methods in Python. So over on the left here, we have some code which we looked at in the last object-oriented video, which is basically just a class of a person with a number of methods inside it. If you look at the bottom, I've created an instance person1, and then I'm trying to print person1. Now, if we try to run this code, we'll see that printing a person object prints person object at and then a memory address. So why does this happen? Python allows us to print a number of different data types. For example, I can print a string, and I can also print a number. Since Python's library implementation has defined that when we print a number, we want to convert it to a string first and then print it. However, when we define our own type or class, such as person, we haven't told Python what we want it to look like when we convert it to a string. So it results to the default implementation, which is to print a pointer. However, Python allows us to override this default string method. So to do this, I can write def, and then the name of the method we're overriding is string with double underscores, so str. And in this method, we just want to return a string, and it's up to you to choose how you want to represent that object when it's converted to a string. So for the person class, let's make the string method return the first name and the last name. Now if I run this code again, you'll see that when I'm trying to print person1, it's printing the name, John Smith. Alright guys, that's all for this video on abstract classes, inheritance, and method overriding. Thanks for listening.